Okay, welcome back. We're still in section 216. We're continuing on with more of these geometric sequences. Remember, geometric are exponential. They're in that form of y equals a times b to the x. A is our initial, and b is our multiplier. So what we're going to do is we're going to find our initial. So A is term 0, that's 1600. Now we have to find the multiplier. To find the multiplier, we're going to take the second number and divide by the first. So we can look, 2000 divided by 1600, that's going to be 1.25. Then I can make sure that it's constant. So I can do 2500 divided by 2000, and that gives us 1.25. And you can keep dividing, and you'll see that that multiplier is consistent. It's constant. So B is 1.25. So T of n, the initial, 1,600, 1.25 to the n. There is our geometric sequence. Next, for part B, the initial, A, is going to be 3,906.25. And now we need to find our multiplier. You can see our values are going down, so our multiplier should be less than 1. So keep that in mind. If they're going down, the multiplier is less than 1. If they're going up, the multiplier is greater than 1. So 3,125 divided by 3,906.25. You divide those, you get 0.8. You divide 2,500 by 3,125, you get the same value, 0.8, and you can keep checking as well. So that B is 0.8. So T of n equals 3,906.25 times 0.8 to the n. There is our geometric sequence. Next, for part C, our initial is 50. That's our value for A. And now we need to find our multiplier. You can see they're going up, so our multiplier should be greater than 1. So you want to think, to make sure you're dividing properly, what kind of number you should end up with. So it's going to be 72 divided by 50. Which is 1.44. 103.68 divided by 72, you're going to get 1.44. That's our multiplier. T of n equals our initial, 50, times 1.44 to the n. Okay, so what we're doing for part D, we're missing things. Remember, we're multiplying to get from one number to the next. It's going up, so our multiplier should be greater than 1. So to get from 50 to 72, we're multiplying by B and then by B again. So if we write this out, 50 times B equals 72. So divide both sides by 50. B times B is B squared, and that equals 1.44. But we need to find out what B is. So to undo squaring, we're going to take the square root of both sides. So B equals, we're only going to take the positive value of 1.2, and that's our value for B. So 50 times 1.2, we're going to get 60. 72 times 1.2 would be 86.4. If you multiply that by 1.2, you're going to get 103.68. Multiply that by 1.2, you're going to get 124.416. Now, to go backwards, it's going to be 50 divided by 1.2, and and that would give you about 41.67. I'm going to round it just for ease. That's our value for A. So T of n equals 41.67 times 1.2 to the n. That's a more complicated one. Like I said, we're going to continue working on these in the next few sections as well. On the next page, if you remember that first problem we did in this chapter, the multiplying by bunnies, we found the equation y equals 2 times 2 to the x. Now they have over 30 million rabbits. How many months have passed? So we have here is 30 million. Remember, this is a perfect world where all of the bunnies live forever and everything is perfect. So what we could do is we could divide both sides by 2 because we need to solve for x, the number of months. So 15 million equals 2 to the x. We're going to do a guess and check again. So if I pull up my calculator, try that again. So 2 to the x equals 15 million. I think I need a pretty big number, so I'm going to try 2 to the 20th. That's only 1 million. So let's try 30. 2 to the 30th. That's 107 million. We went way over. So let's try something smaller. 2 to the, keep hitting the wrong button, 2 to the 21st. 2 million, we're getting closer. 2 to the 22nd. Getting closer. Let's try 2 to the 23rd. 8 million. 2 to the 24th. Remember, we're trying to get to 15 million. That's 16 million, almost 17 million. So 23 months, we're at just over 8 million. At 24 months, we're over 16 million. So we're somewhere between 23 and 24 months that we would have that many rabbits. So let's just say about 24 months. It's between 23 and 24 months that we'd have that many rabbits. So with that many bunnies, the bunny farm or the rabbit farm is getting overcrowded, and some are having, we're going to skip that one. The model would be T of n equals 30 million. That's our starting. Times our decay. It's going down. It's going to be 1 minus the rate of 0.3 to the n. So T of n equals 30 million times 0.7 to the n. Growth is when that multiplier is greater than 1. Decay is when the multiplier is less than 1. Last one, percentage multipliers. I kind of like this question. Karen works for a department store and receives 20% discount on any purchase. They're also having a clearance sale with everything marked 30% off the regular price. She's going to buy $100 of dresses that she's wanted, includes her employee discount with the sale discount. What is the total discount she will receive? Does it matter which discount she takes first? And I think this is a cool question. So we're going to use the first grid to represent when we're taking the 20% discount and then the 30% discount. Then we're going to use the other one to go the other way. So a 20% discount, 20% of 100 is 80. Or 20, excuse me. So we're going to take out 20 of the bricks. So we have 80 total remaining. Now we're going to do the 30% discount. So then we're going to take off 80 times 0.3, which is 24. We're going to take off another 24. So you can see the number of bricks we have remaining, if you count them up, is 56. So she would owe $56. Now if we do the 30% discount first, we're taking $30 off right away. There in rows of 10 makes it a little bit easier to work with. Now we're left with 70 blocks remaining. 70 times 20%, or 0.2, is going to be 14. So we're going to now take off 14 more bricks, or 14 more blocks. Cross off the other side. So you can see, if you count them up, we have the same number of blocks remaining, 56. It doesn't matter which one you do first. It doesn't matter which one you do first. It's going to still be the same, $56 in the end. We're going to stop there, and I'll see you again for another practice of talking about sequences versus functions.